This is part 2 video on building design demonstration using STAAD software. In the previous video, the problem statement, that is the description of the building for which the analysis and design has to be carried out, was discussed. Now, in this part 2 video, we will discuss about the geometric modeling of the proposed building in STAAD software. In order to model this building in STAAD software, we would like to know the location of the columns, the layout of plinth beams, roof beams, and the beam which has to be provided in the headroom. So all those details will be required so that the building can be modeled in STAAD. Here you have this column center line diagram, and the position of the column is given with reference to the intersection of the vertical and horizontal grids. All right. So what I will be doing, I'll be looking into the columns position with reference to the intersection of vertical and horizontal grids. So I'll define the node points which will tell me about the location of the column. As can be seen, some of the columns, say for example this column. Okay, so this column is A dash 3. Okay, vertical grid is A dash, horizontal grid is 3. So I can say this is A dash 3 column. The center line of this column is not passing through grid 3. However, I'll define the nodes exactly at the intersection of grid 3 and A dash, but later when I define the properties, I will provide a specification of giving an offset to this column by 145 mm. So whenever you make a column center line diagram, always indicate by how much the center line of the column is having an offset with the grid line, because this will be helpful for you when you want your analytical model of STAAD to match with the physical model or the actual structure which will be present. So let us provide the nodal points which will represent the position of the columns. So first I'll be working at the plinth beam level. So at the plinth beam level, I'll be drawing the location of these columns. Okay. Say if this is my origin, I would like to provide along the vertical grid A how many columns? 1, 2, 3, 4, 5. If I create one node by using translational repeat command, I can give the nodal location of this 5 column which is lying in grid A. Next, what I can do, I can again select all these nodes of grid A and do translational repeat in x direction for 3 plus 3.36, that is 6.36 meter, and I can make these columns. Further, I can create these two columns by making copy and paste of these nodes at a distance of 3 meters. So let us do this. So let me create one of the nodes. Alright, so one of the node has been created. I'll go to select or node cursor. This has been selected. I'll go to geometry and select this translational repeat. This node has been created considering this point as origin. This is my x-axis, and along this we have z-axis. So whatever column we have to put along grid A, these are along negative z direction. So when I do the translational repeat 5 times of this node in order to locate these columns, that is this column 1, 2, 3, 4 and 5. So whatever the spacing we see, I have to give the spacing as minus 5.7, minus 3.59 and so on. So let us do that. So I am going to do the translational repeat along z axis, okay, in the z direction. Number of step is 5, okay. And what was the distance? It has to be like first step is at a distance of minus 5.7, minus 5.7. Next one is at minus 3.59, minus 3.59. Similarly, the third step at minus 2.89, minus 2.89. Then we have minus 3.44 and minus 5.58. Minus 3.44. Then we have minus 5.58. Okay, and I'll be linking this step because I know that columns along this grid A is going to be connected by plinth beam. Okay, let us do that. Click link steps, click OK. See, we have created the columns along grid A, and these nodes are actually the locations of the columns, and this beam which is connecting these nodes are nothing but plinth beam along grid A. Now what I will do, I'll press escape. This is my beam cursor. Select this, and I'll be doing the translational repeat in the x direction. Okay, as you can see, these members and column has to be copied along the grid B. At what distance? 6.36 meter. Okay, and again I will be doing the translational repeat. The beams have been selected, so let us go with the translational repeat. It has to be in the, this has to be copied in the x direction, and how many step? One step. And how much distance? 6.36. So 6.36, and I link these steps because you can see when it is getting copied, I need the plinth beam along these direction also, along x direction. All right, I'll click OK. I'll go to view, see the top view. So here you see you have created grid A and grid B, and the plinth beams have also been connected. Now apart from this, you have two columns as can be seen. Okay, here is the position of these two columns. I will see this is grid 1, grid 2, grid 3, grid 4. So along grid 3 and 4, you have column along A dash axis. So I'll select these two nodes and paste these nodes at a distance of 3 meter. So let us do that. 1, 2, 3, 4. So select node cursor. So these are the nodes in the grid 3, 4. Control C, Control V. Now this has to be copied along X direction at what distance? 3 meter. Click OK. Okay, we have created the nodes which is representing the position of the columns, and also these columns are being connected by the plinth beam using these beam elements. But there are also other plinth beam which need to be joined. Say if I see here, you can see here one plinth beam has to be there which joins these two columns. So what we'll do, we will join these two nodes. Okay, so fine. So now the plinth beam layout is ready, and you can compare this plan with the plinth beam layout which you have. Next, we know that these plinth beam is going to be located just below the ground level, and I would like to know what is the depth of the foundation below ground level, because column is going to extend beyond these plinth level up till the foundation depth. So what is the foundation depth? It is 2.1 meter. So what I'll do, I'll go to select node cursor. I'll select all the nodes because these nodes are what? These nodes are showing me the location of the column. And I'll go to geometry. I'll make the translational repeat, and I'm going to copy these nodes below plinth level to mark the location of the foundation. So what is the foundation depth? It is 2.1 meter, and when I link steps, my columns will also be created. Please note you give default step spacing as minus 2.1 meter because it has to go below a plinth level. So that is why I'll go with minus 2.1 meter with the link steps option checked. Click OK. Let me view the isometric view. Here you see this is the plinth level, and below plinth level these columns are going up till the foundation level. Now let us create a column and beam up to first floor level, because after first floor level the beam layout, okay, the beam layout is going to be same for the second floor level and for the third floor level also. So for doing that, what I will do, I will view the plinth level again. Now in order to view the plinth level, I'll see this structure from the front view. Press escape to select the beam cursor, make this rubber band selection, and go with the selected objects. So if I see the isometric view, I can again see the plinth level. I will select the entire structure because this structure is going to be present in the first floor level also. Okay, as can be seen from here, you can see some of the beams are getting copied at the first floor level also. Okay, we'll be creating the other beams which are not going to be present for what we are copying in our STAAD model. So let us do that. So at what distance I should copy? Now to know that, I'll look into the section, say section BB. So it is showing me, it is giving me an idea above plinth level at a distance of 2.85 meter, the beams are present at the first floor level. So I'll select this. I will go with the geometry. I'll select geometry option, click translational repeat, copy this in the vertical y direction at what spacing 2.85 meter, and I will go with the link steps. Click OK. So this is your first floor level. Let me see the first floor level because I would like to create the beam layout at the first floor level too. So for that, go to view, see the front view, make this rubber band selection, view selected objects, and you can select this isometric view. Okay. Now let us move to the layout of the beam at first floor level. Here it is. Now you see, you have one beam at a distance of 3.32 meter from this grid line. So what I can do, I can copy this beam and paste this beam at a distance of 3.32 meter. So let us do that. This beam, Control C, the member is copied, Control V. So it has to be copied in the Z direction, positive Z direction, 3.32 meter. Click OK. See, this is done. So you have created this beam. Next, I need to create this beam, and this beam. This beam is located at a distance of 3.12 meter from this grid. Okay. So I'll select this beam, Control C, Control V. At what distance? So it is to be copied along X direction at a distance of 3.12 meter. Click OK. See, this beam has also been created. Okay. Next, I would like to create this beam and this beam. So this beam is located at a distance of 1.42 meter from this grid, and this beam, it is located at a distance of 4.26 meter again from this grid. So let us copy this beam and paste it over here. So I'll copy this, Control C, Control V along X, 1.42 meter. Click OK. Done. See, select here. Since this beam was already copied, I'll again do Control V. At what distance? 4.26 meter. Control V, 4.26 meter. Click OK. You see, this beam, this beam, this beam, and this beam has been created. Next what? I'll move further. I can see a presence of beam on a presence of beam over here, and the beam which connects these two columns is not being the beam which connects these two columns is not present. So what I'll do, I'll delete this. Okay, I'll delete this because this beam is not present. But yes, there is a beam which passes through this column to this beam, as can be seen over here, from this column to this beam. So what I will do, I'll go to geometry under add beam. You can see the small triangle. I'll click this. A perpendicular intersection. I'll select this one. Select this node, and I'll just select anywhere in this beam, and I get a perpendicular beam. Okay, which is perpendicular to this beam. So this beam is being created. Similarly, if I scroll it down, here in between these two grids, you have this beam and this beam. This beam is located at a distance of what? Distance at a distance of 1.69 meter. So let us copy this beam. Okay, Control C, Control V. So in the negative x direction, so minus 1.69 meter. Click OK. Done. Further, you have this beam which has to be located at a distance of 1.29 meter or 1.6 meter from this grid or from this grid. So what I will do, I will select a beam which has been created in the STAAD here, and I will paste it at a distance of 1.29 meter in the Z direction. Control C, Control V, the positive Z direction, 1.29 meter. Okay. So what you can see, I have created these roof beams, and please note the location of roof beam is such that it supports the wall which is going to be present at the first floor level. So based upon the plan, wherever we had the walls in the first floor level, below that I am providing these beams. Okay. So what I've done, I have finished the layout of beam up till this level. Further, let me see. From this column, I have a beam which intersects the beam over here. Let us do that. So from here, one beam has to be there which intersects this beam. So again, I'll go to add beam, perpendicular intersection. I'll click this node and paste over here. See, this is done. Next, what? Further, I'll cool it down. You see, there are four more beam. Okay, but these two beams has to intersect this beam. So I would like to create this beam first. So this beam is located at a distance of 3.2 meter from this grid. So let us do that also. Press escape, Control C, Control V in the negative Z direction. So minus 3.2 meter. Click OK. Fine. So this beam has been created. This beam. And what I can do, I can copy a beam element over here and copy at a distance of 1.42 meter and 4.26 meter along x direction. Control C, Control V, 1.42. Click OK. Click once in this view window. Then again Control V. At what distance? 4.26 meter. See? So you have done this. Next, to provide this beam, which is placed at a distance of 3.24 meter from this grid line. Let's select this, Control C, Control V, long X, 3.24 meter. Okay, so this gives me a complete layout of the roof beams, but still you have some periphery beams which need to be placed, and you are providing these periphery beams to give an additional support to the balconies, okay, which is going to project beyond these grid lines. So as per this layout, you can see from this grid line, the position of these periphery beams is located at a distance of 1.04 meter. So what I'll do, I'll select these beams, do translational repeat along Z. There is 1.04 meter, and I link steps. If I do that, you see these members are also created. So these are periphery beams, and additional these three beams you can also see in the layout drawing. Further in this direction also, you can see these are the periphery beams. At what distance it is located, I'll select these three beams. I'll make a translational repeat at a distance of 0.92 meter along x direction. So let us do that. 2, 3, 4. I've selected this, so you can see 1, 2, 3, 4. And I'll select these beams also. Okay, because if you see, if you observe, 1, 2, 3. Alright, so these are also your periphery beams. So let us go with the translational repeat along x direction. Once step 1, 0.92 meter, link steps, click OK. So I'll go to select view, see the top view. Now this is what? This is the roof beam layout at first floor level which you have made. Okay, so let us go with display hole structure. Here you can see the columns, plinth beams, and the beams at the first floor level. I know that the first floor level, whatever beams you have, the same beams is going to be located at the second floor level and at third floor level also. Now, before copying this roof beam at first floor level, it is suggested that you define the properties of the column, plinth beams, and roof beams. Later, when I copy the roof beam of first floor level, the same property is going to be assigned for the subsequent floors also. Okay, so let me click properties. What is the property of the column? Here you see the property of the column. There are two types of column. If you observe, you have 240 by 480 column and 240 by 530 column. Let me show you. If I see here these two columns, what we have is having dimension of the column as 240 by 530 column. Rest all column is of 240 by 480 Okay, so this is in the grade 3. All right, so we have to remember that. Let us create the properties. Define rectangle. Give this dimension as 0.24 and this dimension as 0.48. Later I'll be changing my orientation of the column. Okay, so I know based on local axis your YD and ZD has been defined, but depending upon the layout of the column which is actually proposed, okay, as per the column layout, I would be changing the orientation of the column later. So I'll click add. Next is 0.24 by 0.53. The material I'm selecting is concrete. Click add. Next about the plinth beam. The plinth beam, it is 240 by 420 Okay, the depth is 0.42, wide is the depth, and ZD is the width of the beam, which is 0.24. Click add. Next, the roof beams. Roof beam is 240 by 450. So this is 0.45 and the width is 0.24. Click add. Lastly, the periphery beam. Let us say the periphery beam is having a width of 0.2 and the depth is 0.4. Okay, so this is the trial dimension with which I'm giving the edge beam of balconies. Click add. So all the properties has been defined. What we have to do is to assign the properties to the columns. So first let us assign this property, that is 240 by 480 size column. So for that I'll go with select under beams parallel to Y. Okay, and as I said, our in the grid 3, this column, this column is not having dimension of 240 by 480. Rest all selected columns which you can see is of dimension 240 by 480. So I'll assign this. It has been assigned. What about 240 by 530 column? I'll select this. So this has to be for this column which is in grid 3. Okay. Done. What about plinth beam? So let me view from the front. This is my the plinth beam is of 240 by 420 I'll select this beam and I'll make a rubber band selection at this particular level. You see the plinth beam has been selected. So I'll assign this property. Done. Next I am going to assign the property of 240 by 450 for the roof beam except periphery beams. Okay, so again I'll go with the front view selection. I'll make this selection. Okay, so you see this has been selected. These two beams should not be selected. Also I'll make sure that these beams are of dimension 240 by 450. Now click assign. Done. Next I have to only select the periphery beams. I'll select the periphery beams. These are my periphery beams. The periphery beams have been selected. So let us go with selected objects. These are the periphery beams. So by mistake, the property of 240 by 420 has been assigned. So that will go if I select 200 by 400 and go with assign to view. You see, whatever property was assigned has been removed. Next, I'll display whole structure. So I have completed the definition of the properties for the columns, plinth beam, and roof beam at the first floor level. Now let me see the 3D rendering view. Okay, so here you see that you have defined the properties to all beam elements. Okay. Next, I would like to correct the orientation of the column. Okay, because as I said, the orientation of the column you have defined 240 by 480. So it is going to be in the same orientation. Now, in order to show that, let me select this 240 by 480. It is highlighting these columns. Let me select these selected objects. You can see these columns have been selected. Let me go to label settings, go to structure, and select under 3D section full section. Click apply. What you can see, so say if I see from the top, let me go to geometry and again go to view, label settings, structure, full sections. So what you can observe, that these columns are having, all the column have larger dimension along a z direction. But if I see the column layout, what you can observe, there are certain columns which is not having the larger dimension along z axis. Say this column along grid 4, these two columns, and then in grid 2 this column, and in grid 5 this column. So there are total 1 2 3 4 columns which is not oriented such that the longer dimension is along z axis. So I need to change its orientation. So what I'll do, in grid 5 I'll select this column, and in grid 4 this column, and in grid 2 this column. Right, so let us do that. One of the column is not being selected. Let me display whole structure. Okay, so I'll go to select parallel to y. So all the columns, vertical columns, has been selected. And I'll go with view, selected objects only. See the top view. Okay, so grid 1 2 3 4 5, this column. Okay, so this column has been selected. As you can see, this column has been selected. I'll press Control key. Now in grid 4, you see these two columns. Okay, 1 2 3 4, these two columns, and finally grid 2, this column. As you can see, you can observe these 4 columns is not having the correct orientation. Now to change the orientation, you click property, go to beta angle, click create beta angle. I need to rotate this section by 90 degree. Okay, so whatever section you have, I want to rotate it by 90 degree. So if I do that 90 degree, click OK, select beta 90 degree. Okay, select beta 90 degree, select these columns, grid 5 column, then grid 4 column, and then grid 2 column. And let me assign this, assign to selected beam. Click assign. If I do this, now let me go to view, under label settings, go to structures, see full section, click apply. What you can observe, now let me show the top view. What you can see, in grid 5 the orientation of this column has changed, in grid 4 the orientation has changed, and in grid 2 also the orientation has changed. Okay, so this is one thing which you have to do. Next, once this is done, next display whole structure. Let me see the plinth level. Okay, let me see the plinth level. I'll see the front view. This is the plinth level which I have. Okay, let me select the members at the plinth level. You see it is selected. I'll go with the selected objects only. Okay, Next, I'll see the top view. I'll see the top view, and let me go to geometry first. Go to view, label setting, structures, full sections. Apply. Okay. So here you can observe you have column here, beams. Now please observe this beam. Okay, let me focus here and show you. Now this beam is flushed to this face. It is not lying exactly at the center of this column. So what we have to do? We have to use offset command such that this face of the beam flushes to this face of the column and this face of the column. Now how you can do that? By how much I have to shift? Since it's a center line, I need to shift it by how much? 120 mm. Since this dimension is 480 mm, so if I shift by 120 mm, you see what happens. I need to shift this beam about z axis such that the face of this beam flushes with the outer face of the column as we had seen. Okay, so what I do, I'll go to specification. I need to provide an offset to the start point of the beam and to the end point of the beam. Please see, if I hover over here to this beam, green is start and blue is end point. So I need to make an offset to the start point and end point of the beam by 0.12 meters such that the face of the beam flushes with the outer face of the column, and I'll show you how exactly it is happening. So I'll click specification, click beam, offset, start point I'll select. About z axis I have to move the beam 0.12 meter, click add. Similarly click beam, again click offset, click end, and again z is by how much it is moving. This beam has to be moved in this direction, that is negative z direction, so it has to be minus 0.12 meter. Okay, click add. Now let me make the correction for the start over here. It has to be minus 0.12 meter. Click change. Let us assign the start to this beam. So use cursor to assign. See, it has offset. The start point has offset. Similarly, this end point has to also offset. You see. Let me show you the change. Go to view, label settings, structure, full sections. Click apply. Now I'll try to zoom. What you can observe, this outer face of this beam has flushed with this particular column. So this has been achieved. Similarly, let us observe orientations. So this beam is done perfectly. What about this beam? So this beam has to offset in the positive z direction. All right. So let me, because this beam is not passing exactly through the center line. So let me come to the this grid. This grid. Okay. In order to observe this, let me make this selection. Okay. I've selected this. I'll go with the selected objects only and see the top view. So what change you can see? The center line of this column. So let me come to the column center line. As you can see, the center line of this column and this column is not matching. So I have to make an offset of 120 mm to this column. Okay. So what I'll do, I will see the whole structure. I'll see the whole structure. So this column, which is passing through this grid, has to be what? Has to be given an offset of how much? 120 mm and the positive z direction. So I have to select this column. Okay, I have to select this column. So I'll go to the top view. So I know here this column is lying. I'll make a rubber band selection like this. You see, this column is being selected. I'll selected objects only. Next, I'll select the column. Again, selected objects only. Here is you see. So this column has to be given an offset of how much? 0.12 meter, because the center line of this column is not passing through the grid line. So I'll go with beam, okay, offset, so about z, positive z, so it will be 0.12 meter, start, okay, and similarly beam again, offset, and this is 0.12, click, add. So let me assign to this beam the start, assign, yes, assign to selected view, similarly select this, assign to selected view, click assign, you see, this is done. Now to see the change, display whole structure, okay, see the top view, let me select like this, selected objects only. Next what, you can see this beam. This beam has to also shift by 0.12 meter along a positive z direction, start point and end point, okay. So what to do next, I'll select these beams, select start point, okay. Let me see, be very careful when you are using this. So this beam has to move by 0.12 meter, start as well as end, and also to this beams also, okay. Click assign, so we will go to this beam, click assign. Okay, so right now the diagram may not be very clear to you, but what I can suggest, you go to view, go to 3D rendering view in order to see the changes. I was making this change in my switch grid. Let me show you the first plinth beam along grid 5. You see, this is the beam. It flushes on this column with the periphery being flushed to this face. So same thing I would like to see at the plinth beam level also. So in order to see these changes, let me go to go to geometry, go to view, display whole structure, and let me select the front view. Let me select this, and go with selected objects only, and let me go to 3D rendering view. So I know this is grid number 5. You see, this column is flushed on this face of the column, and this face of the beam is flushed with this face. Okay, same thing can be good, and you can observe this. See, so you have to use this offset command suitably in order to match the analytical model with the physical model. Okay, so you have to do this. So let me complete this exercise. Next, let me see the beam layout again. Here you can see the change. What I can find, let me come to column center line. What can be observed, that the center line of this column, okay, it is not matching. It is having an offset of 120 mm. Okay. Similarly, the center line of this column, it is not matching, and this column is also having offset of 120 mm. Please observe, the offset of 120 mm should be in the x direction here, and the offset of this particular column has to be by how much? It has to move by 120 mm in the z direction. So let us do that first. So I'm working now in grid number what? Grid number 4. Okay, grid number 4. So in order to do that, let me tell you, this is my grid number 654. What I'll do, I'll go to select node cursor. You see what is the node number 17. So I'll select XY plane which contains node 17, because that will ease my work. I'll go to utilities, under utilities, go to structural tools, click cut section. I want to see XY plane which contains node number 17. Okay, so here it is. So I know that this column, okay, this column has to be given an offset of how much? 120 mm in the x direction. Okay, these two columns actually. So grid number 4 column and grid number 3 column. Okay, let me do this for this column first. Define beam offset about x, how much? It was 0.12 meter in the positive x direction. Click add. Similarly, click beam offset and 0.12 meter. Click add. So to this column, I'll define start of offset of 0.12 meter, assign, and for end also I'm going to. So it has been shifted. So this column has been shifted inside, okay, because the center line is lying on the right hand side on the center line. Now similarly, the center line of this column is lying above this grid. So this column has to be shifted above, okay, above this grid line by 0.12 meter. So let me select this column. I've already start minus 0.12 meter, which is for Z. I'll select this, click assign, and end also I'll assign. So this is done. Okay, let me see the rendered view. Here you see this coming perfect. Okay, it is coming perfect. These is getting joined, and here I am having the offset in this particular column. Let me show you the plinth beam. This plinth beam center line is passing exactly through the grid point, so I should not change anything. So grid 5, grid 4 is done. Let me come to grid number 3. So in grid 3, what I can observe, again this column has to be shifted by 120 mm in the x direction because its center line has shifted from the grid line. Okay, then whatever column I had defined, it defined the center point, that is this grid point, intersection of the grid point. So it has to shift by 0.12 meter in the x direction. Let me go to geometry, view, display whole structure. So grid 4 is done, so I want to do the changes for grid 3. I'll go to select node cursor, and this is how much? 18. Okay. Utilities, structural tools, cut section, XY plane, 18. Click OK. But go to specification. So this has to shift. Let's start 0.12 meter in the x direction. So I'll click assign. Okay, I'll click end. This is done. Okay. Next, see the center line of this beam is merging with the grid line, so I do not need to do any offset, but this beam has to be done because the center line of this beam is not passing through the grid point and there is some offset. These two columns also have an offset of 145 mm from this grid point, and it is in which direction? In the positive Z direction. So I have to create an offset command again. Beam offset start about Z 0.145. Click add. Similarly, click beam offset 0.145. Click add. So this has to be assigned to which column? This column, this column, this column, this column. Similarly, this has to be not be start. This should be end. Change. I'll assign this. So yeah. So this has been done. The center line of this plinth beam is not in line with the this grid line. So there is some offset. So by how much it is moving? So from geometry, what we'll do? So we know that this grid line and the center line of this column is how much? It is 145. Okay, from here to here it is 145. Okay. Next, if I see the center line of this particular beam with reference to this one, so from here to here it will be 120. Okay, it is going to be 120. And next, I want to know from here to here what is this distance. So this dimension is 530. So 530 divided by 2 is 265. Okay, so 265 minus 120, 145. So from here to here it is 145. and again from this to this distance it is 145. So total it is 290 mm. Okay, it is going to be 290 mm. As can be seen, it is what was 145. 145 and 145, it is 290 mm. So we have to give an offset of how much? 290 mm to the beam which is being shown over here. I'll go with the beam. Again, offset, start about z axis. I have to shift. It is 0.29. Add. Similarly, beam. Again, offset and 0.29. So this I have to assign to this assignment method, which I'm going to choose is to assign for the selected beam. So I'll click yes. Okay, and click even end. Click assign. Same thing I'll do with this beam also, because if I see the roof beam plan, okay, so here you can observe, so this has to also shift. Assign, assign. Let me see the rendered view of this. Okay, one more thing, you can see this column is having an orientation like this, which is not matching. This orientation of this column has to change, so I have to define beta. So that can also be done. What I will do, I will select these two columns. So I have done in property, this beta angle has been defined. Select beta 90, select these two columns and click assign. See, now I'll go see the rendered view. Go to select all these members, go to view, 3D rendering. Now this is fine. So this is what I wanted in my physical model also. The column orientation here, this is another column, this is another column, such that this face flushes with these two faces of this column. Okay, so this is done. So we are done with grid 3. Let me see the grid 2. When I come to grid 2, it is advisable you see the center line of the column in grid 2. I can observe that this column center line is not matching with the grid 2. It has shifted downward. So this column has to be given an offset of 120 mm in the positive z direction. What I'll do, I'll display whole structure. I need to go to grid 2, right? So select node cursor. This is node number 19. So go to utilities, structural tools, cut section. I want to see XY plane which contains node number 19. Click OK. So here you see. I'll go to specification. Already the offset of z 0.12 meter is been defined. Here you see start. Okay, this is for z. You can see. So I can assign this column and this column. Similarly, and to this column and this column. So it has been done. Okay, so it has been assigned. Next, if I see the plinth beam layout, the plinth beam, the center line of the plinth beam is along the grid axis, so I don't need to do any offset. Here I need to do the offset. By how much the offset has to be? The offset has to be by 120 meter about positive z axis, because the center line of this beam is not in line with this grid 1. Let me go to view, display whole structure. So what I want we select this view 20, go to utilities, structural tools, cut section. I want XY plane which contains node number 20 here. So what I do, I want to shift these beams. Okay, so in the z axis, about z axis, positive, assign, select start, assign. This is done. Let us view the whole structure. Let me go to 3D rendering. You see, this is what actually I wanted. Next, once this is ready, we can easily model the further floor of the building. What has to be done? If I see this section, I have created the ground floor. Height of this column is 2.85 meter, and in the first floor, these columns was also having 2.85 meter. In the second floor also, the column is having a height of 2.85 meter. The third floor also, the column is having a height of 2.85 meter. So I can copy the geometry over here and I can paste it at a distance of what? 2.85 meter, 3 times. So let me do that. So let me go to view, see the front view. This has to be copied, okay, because this is my plinth level. Below plinth level, I have the column which will go below ground level. These selection which I have made, this has to be copied 3 times. Okay, this has to be copied how many times? 1, 2, 3 times. I'll go to geometry, translational repeat about y. How many steps? 3 steps. And what height? 2.85 meter, as you can see here. 2.85 meter. Okay, and I'll not link steps now because I'm copying everything above this. I'll click OK. What you do? You go to view. You see the 3D rendering. You see the geometry is ready. Only thing is what I need to make headroom at the staircase and lift area, which is being positioned over here. Now to do that, I will see the section. Here is the section. So up till this level I have created. This is the headroom. Now the headroom, whatever column we have, it has to be copied up to a distance of 2.4 meter. But this entire area is going to be our headroom, right? Let's do that. I'll go to geometry. Okay, let us see the front view. This is my front view. Let me select this level. Selected objects only. See the isometric view. So what has to be done? I need to create the columns and beams for the headroom, and the plan which you can see. Okay, at the headroom, these columns are there, and these are the positions for the beams. So what I'll be doing, I'll select this beams over here. I know that these beams are going to be there in the headroom. I'll go with translational repeat command about y, 1 step, and what is the distance? 2.4 meter, and I will go with the link steps also. Click OK. See, this has been done. Next, I will see the front view. You can see the front view. I'll select this, okay, and selected objects only, isometric view. Now, if I select this entire thing and if I see the 3D rendering view, you see whatever links were joined, those column property has not come here. Okay, those column properties has not come, and these beams I'm having, but there should be one more beam which should connect these two columns, because if you see, these two columns are getting connected by this beam. So that we have to do. So let us go to geometry, click add beam. So this is created. Let me define the properties of this beam. Go to properties. Say this beam is 240 by 420. Click assign. What about these columns? So these columns should also be given all the properties. Please observe these columns are not here. Okay, since I use link step, you don't have these columns. You have only 1, 2, 3, 4, 5, 6 columns. So let me assign the properties to these columns. 240 by 480. Click assign. See. Now let me see the rendered view also. Fine. This is what I wanted, but I need to confirm it. Let me display the whole structure. Click geometry in order to avoid this, and go to view, see the 3D rendering view to confirm whether I have done it correctly or not. So what I can observe at the headroom level, okay, at the headroom level, if you observe, the orientation of these two columns are not matching, so I have to rotate it. What about the columns over here? So here also, you see I have to apply the offset. Okay, I have to apply the offset. So these things you have to perform so that it matches. Please observe. Let me show you in this fashion. Go to view, see the plant. I have to focus on this area. Okay, go to selected objects only and 3D rendering. Now picture is going to be more clear to you. Here you see this column has to be oriented, and the beta angle has to be specified. Even for this column also, beta angle has to be specified. This has to be given an offset of 145 mm. This column also be given an offset of 145 mm, and this has to be also given an offset. So let us do that. Go to properties. Let me see the isometric view. First I'll go to beta angle. Right, so here you can see beta 90 degrees. So this column has to be assigned what? Rotation of 90 degree. Okay, if I select this, I can select these columns and I can click assign. Okay, next these two columns has to be given an offset. Okay, by how much? Let me show you the plan. Column center line, it has to be given an offset of 120 mm along x axis. So we'll do that. We'll select these two columns with specification 120 mm in the x direction. Here you see x 120 is already defined. So click, let us use cursor to assign this one, what about end? Again this one. So this is done. Next I need to give offset of 145 mm to these two columns also. So that was also defined. Here you see offset to this column and this column, and then end this column and this column. Now you try to see the select entire this staircase part and the lift room part of the structure. Go to view, 3D rendering view, and observe whether you have done the modeling correctly or not. You see the column is coming straight, the orientation is correct, this is offset correctly, this is offset correctly. So this is done. So we have completed the geometric modeling of the entire structure. Now in order to see it, you can click view, you can go with the 3D rendering view, and you can observe it has been done as per the requirement in your physical model. Okay, so the analytical model is ready. In our next video, we will see the load calculation part, and systematically we will be applying those loads in this model which we have created.